Climate change, really is one of the greatest threats to global humanity that we're facing at the moment, and it's really only by scientists, mathematicians, physicists, biologists working together to really understand the details of the problem that we can properly inform global policy. Well, applied math and computational science are absolutely critical to helping us understand the world around us, to understand how that's changing. My own speciality is looking at climate change, and we wouldn't be able to start understanding climate change if it wasn't for our understanding of applied math.
One of the main things I study as an applied mathematician is sea ice. And sea ice plays a very important role in our global climate system. One of the most important jobs that sea ice does is in reflecting incoming solar radiation during the polar summer. This white reflective surface reflects much of the solar radiation back into space. And part of the big problem is that we're losing this summer Arctic ice pack at a tremendous rate. Over the past 10, 20 years, we've lost over half of the summer Arctic sea ice pack. So it's a rather dramatic decrease in the ice cover in the Arctic.
The first important aspect of our work is to describe how the world is changing and the risks posed by climate change in terms of how the world might change in the future.
The climate system is a very complicated object. It's described by coupled systems of partial differential equations, which is one of the principal objects of study in applied mathematics. And so the system you're studying, it's applied math. And whereas I think historically much of the studies that have been done on the climate system have been done by atmospheric scientists, oceanographers, people like that, in general, as fields advance, they become inherently more mathematical. And climate science is no different. SCIAM has been a great source of particularly meetings. The SCIAM annual meeting is a particularly important one because you see a broad spectrum of all the kinds of interesting things that are going on throughout the world of applied mathematics, not just in climate-related research.
And the other thing that I think is really important about SCIAM is the ability to use this to speak to a much wider general audience as well, not just to raise the evidence around climate science in a more general public audience, but also, as importantly, to demonstrate the power of mathematics to tackle some of the world's great problems.